Here's an interesting program using 3D graphics. Take a look. As you can see, we're making a cube by creating planes and over time moving the planes into the position of the faces of the cube. And then the whole thing's rotating around. Let me run it again without the rotation. They all start in the same place and then they rotate into their final position. Okay, I'll put the rotation back. So how does this work? First we have this array of arrays. Here's the outermost array, and it contains 6 arrays, 1 for each face. And then there are 3 numbers and a string here that has 3 numbers in it. And the first 3 numbers are how much to rotate on the X, Y, and Z axes. And we never rotate on Z, so these are all zeros. I probably could eliminate that from this. And these strings are the colors. So one of the faces is all red. 2 of the faces are all red. 2 of the faces are all green, and 2 of the faces are all blue. And then all of them have a transparency set to 0.3. If I make the transparency 1, you can see what it looks like. Not nearly as nice. Or maybe you like that, I don't know. There's also this explode factor here. If you have it set to 1, then it just makes a cube. Otherwise, it makes kind of an exploded cube. So I'll put that back. I'll put this back. Then animation frames is how many frames of animation to consume by the process of animating it. So if we want to enjoy it longer, we could double that. And now it takes place over the first 600 animation frames, over the first 600 times that the draw function is called. And if you wanted it to go faster, you make that shorter. What else could we change? You can change the colors. I explored making a dodecahedron, which is made out of 20 pentagons. The math was just too much for me. I'd love to learn that at some point, but it was too much. Okay, let's talk about how this works. Let's look at setup here. We create the canvas, 500 by 500 3D. We set the angle mode to degrees. We're working with degrees rather than radians in this program. Degrees are probably more familiar to many. And edge length is the size of an edge. And I've talked about the explode. I've talked about these next 3. All right, the rest is in the draw function. And you see it just is these lines from 20 to 32. And what does it do? Well, first, we have to know how far done we are so that we can rotate things into the right way based on the fraction of the doneness we have. So this is sort of a doneness fraction. It starts at 0 and it stops at 1 when the animation is complete. We have the background of light blue. We don't stroke these planes when we draw them. We have this rotate on Y that makes the whole thing rotate now. And then we do something for each face. So remember, faces is this array of numbers and strings. And for each face, we set the fill color using this RGBA. That's red, green, blue, and alpha. And the alpha channel is for transparency. So we use these strings for the colors, and then the transparency value, now 0.3 for the transparency. Then we surround the rest of it with push and pops so that the transformations for the faces don't accumulate. And then here's a loop we're going to call the rotate X, rotate Y, and rotate Z functions. And for each of those functions, we'll call it, and we will take the face sub I, which is one of these 3 numbers. This is the X rotation, Y rotation, Z rotation. And then we multiply it by the doneness. So the doneness, just to show you, kind of illustrate what that is, if we just set the doneness to say 0.5 here and then ignored the rest, it would just always be 50% done. Or if we set it to 1, it would always be just done. So you can see, and set it to 0, that's just the starting place. All 6 planes are in the same space. So there we go. Okay, so when we multiply by the number that goes between 0 and 1, we get some portion of these rotation angles. That's why as time passes, we do the rotations gradually until eventually we're at the final rotation value, which puts the face into its final position. And after the rotation, then we translate, which moves them from the origin out to their distance from the origin where they are now. And we consider the explode factor for that. Then we draw a plane. And I'd say that's all there is to it, but that's kind of complicated. But that's kind of a fun program. So there you go. Hope you enjoy that.